In this next video, in my AIHL series, we're going to be looking at introducing complex numbers. Now, you may have heard of a complex number before. It's given by I, and that is the square root of minus 1. We just call the square root of minus 1 I. Just like numbers are effectively made up, so are imaginary numbers, right? Just because our rules that we've taught so far say that we can never square root a negative number, that doesn't mean we can't, we just define it as such. And there are certain rules that they must follow. So for example, the standard multiplication and addition laws follow. So 2i plus 3i is the same as 2x plus 3x is 5i. Now, the important thing to remember is that I squared is minus 1. So when we're multiplying complex numbers together, when you square I, you get minus 1. So for example, if I have I times 3 plus I, if we use the distributive property, that's the same as 3i plus I squared, which is 3i take away 1. If I do this with double brackets, let's say I have 2 plus I times 5 minus 2i. If we expand the brackets, 2 times 5 is 10. 2 times minus 2 is minus 4, so minus 4i. I times 5 is 5i. And then we've got to be careful here. We've got minus 2 times I squared. But we know that I squared is minus 1. So that's 10 minus 4i plus 5i is just plus I. And then you have minus 2 times minus 1, which is the same as 12 plus I, because the minus times a minus makes a plus. We can use complex numbers to simplify down square roots. So for example, if we have square root of minus 81, that is the same as square root minus 1 times square root 81. This is your basic surds properties. Now square root minus 1 is I, square root 81 is 9, so then that would be I times 9, but we want to write it as this, 9i. Let's say we wanted to square root minus 3. You can write that as root 3i, because the minus comes outside the brackets. Now, a very typical exam question might be something like this. Let's say we've got x squared plus ax plus b equals 0. And I'm going to tell you one solution is 2 plus 3i. What's the other solution? Now, if we think about the quadratic formulae, just the general quadratic formula, so minus b plus or minus square root b squared minus 4ac all over 2a. The complex numbers part comes when you square root a negative. So if I say that b squared minus 4ac is a negative number, when I square root it, that's what gives me the I. Now you can see that there's the plus minus. So what that means is that if you have plus 3i as one of your solutions, the other solution is going to be a minus 3i. Therefore, and this is always the case, if a plus bi is a solution, a minus bi is the other solution. So we know that one solution is 2 plus 3i, that means the other solution is 2 minus 3i. Now if we think to our quadratic rules, what that means is we can say that x squared plus ax plus b is equal to, we're going to take one solution, so minus 2 plus 3i, and we're going to multiply it by the other one, so x minus 2 minus 3i. Now what we're going to do is just expand the brackets and cancel everything down, and you'll be able to then look and find what a is and find what b is. So if I expand the brackets, I get x squared. Now a lot of this is going to cancel, so you just got to be careful. So we're going to do the x times this to start with. So I'm going to have minus x times 2 minus 3i. And then I'm going to have, we'll do the other one, so we'll have another minus x times 2 plus 3i. And at the end we'll have plus 2 plus 3i, 2 minus 3i. So that gives me x squared. Now, if we look carefully, this minus x and that minus 3i will cancel with that minus 3x and that plus 3i, because the minuses cancel, and then they're the opposites. So I'm just left with minus 2x and another minus 2x, which is minus 4x. Now, let's look at expanding this part. You should notice that this is the difference of two squares, because you have 2 plus 3i and 2 minus 3i. So what that means is the 2 times the 3i and the 2 times the minus 3i are going to cancel. All I need to focus on is doing 2 times 2, and then 3i times minus 3i. So 2 times 2 is 4. And then we've got 3i times minus 3i. So it leaves me x squared minus 4x plus 4. We've got I squared is minus 1, and you have a minus there, so those two cancel. So I'm left with plus 9. So I get x squared minus 4x plus 13. And what that means is, if you look back at the question, we have ax is minus 4x, and we have b is 13. So that means that a is minus 4 and b is 13. Let's have another example. Let's say that a plus bi squared is minus 16. Take away 30i. Find a and find b. So if I expand the brackets, I get a squared plus 2abi plus b squared I squared, but the I squared is minus 1, so I get minus b squared equals minus 16 minus 30i. Now there's an important part of complex numbers that says that the reals and the imaginaries have to be separate. So the real part on the left and the real part on the right are the same, the imaginary and the imaginary are the same. So if we look at just the real parts, we've got a squared and minus b squared. The real parts don't have any i's in them. That's minus 16. So we can write out a squared minus b squared equals minus 16. And then we know that 2ab equals minus 30 because the I bits have to be separate as well. So I have 2ab equals minus 30. Solve this on NumWorks, on your graphic displays calculator, and you get a is 3, b is minus 5, or a equals minus 3, b equals 5. The one final thing I want to talk about in this introduction video is complex conjugates. Now we'll talk about this more in the next video when we look at Argand diagrams, but basically if you have a complex number, a plus bi, the complex conjugates, which we say is z star, is a minus bi. Now the reason to do this is quite like when you have surds and you want to rationalize the denominator. Let's say I have a complex number, 3 over 2 minus 3i. This isn't very nice at the moment because you have the complex number bit at the bottom and you want just the i's at the top. What I do is I multiply by the complex conjugate. So I change the sign of the I to be 2 plus 3i. And the reason for this is now that when I multiply the bottom, you'll notice that this is the difference of two squares. So the numerator becomes 6 plus 9i, and the denominator becomes 4 plus 9, exactly the same as the previous example. So it means I get 6 plus 9i over 13.